Coral reefs around the world are experiencing increasing pressures from a variety of different sources, and we're seeing pretty severe declines in a lot of coral reefs around the world. Because our temperatures are warming more and more because of climate change, this phenomenon of bleaching coral is becoming more and more prevalent. So we have two long-term coral resilience projects going on in our house reef here in Shallock. One of the projects here that we do, the Thermal Tolerance Project, is actually seeing if we can identify more resilient donor stock. The idea from this project basically came from anecdotal observations of going out in this very, very shallow bay that's right behind us and seeing that temperatures were consistently exceeding 31, 32 degrees Celsius, which is generally kind of the cutoff of how hot it has to be for pretty much everything to bleach. What we were noticing is that in our really, really shallow fragments that we're experiencing temperatures of what we think are up to 34, 36 degrees, is that at these corals at depths of 1 to 3 meters, nothing was bleaching. So this signaled to us that maybe we have a more resilient donor stock of corals that could be used for restoration here on Koh Tao in our local reefs, but also potentially something that can be more widely applicable to the rest of the world as well. So the first step in that is basically just identifying if we have resistance to bleaching in some of these shallow fragments. And then second of all, testing to see if we can understand if they have differences in bleaching responses compared to our normal restoration fragments that come from about 10 meters, or if they also have different responses to different types of mortality as well. So that's kind of our first step in determining if we have these thermally tolerant corals. Going further from there, if that is the case, then we can look into doing more genetic work to identify maybe what symbiotic clades are giving that benefit, or understanding if that can be scaled up to different areas if it retains its tolerance when transplanted to other areas, or if it's more of an artifact of this specific environment. So what we did was we took fragments of opportunity from our shallow origin donor site, and then we transplanted those along with some of our normal restoration corals. And basically we've now been tracking and monitoring that over the past year, and we'll continue to do so for the next 5 to 10 years, tracking different metrics like bleaching, like different sources of mortality, and also doing growth. So we have a master's student from a university in France right now working on looking at preliminary results from the first full year of data collection on this project. Primarily, he's been looking at size and growth between the two treatment types, but then also we have experienced locally a little bit of a bleaching event. So we've also been going out weekly right now and collecting extra bleaching data through this really, really crucial time. These early results are really, really promising. It does suggest to us that we might have something very, very exciting here and helping us understand a little bit more about building resilience into the future of reefs.